Now, our next topic is writing a molecular formula. Now, in order to write a molecular formula, we have to follow certain steps. And in order to understand these steps, let us follow this example of calcium chloride. Now, calcium chloride is an ionic compound and it is made up of two radicals, calcium radical, that is Ca2 plus, and chloride radical, that is Cl minus. Now, the first step which involves in writing the molecular formula is writing the symbols of the radicals. Now, when we are writing the symbols of the radicals, the first thing that we have to keep in mind is that the positive radical is always written towards the left and the negative radical is always written towards the right. And secondly, that when we write the symbols of radicals, we always ignore their charges. Okay, so for calcium radical, we will write down Ca and we will ignore its charge of +2, and for chloride radical, we will write down Cl and we will ignore its charge of -1. The next step is writing the valency of these symbols. The valencies are always written at the top right corner of the radicals. Now the valency of calcium is 2, so we will write 2 at the top right corner of calcium. The valency of chloride is 1, so we will write 1 at the top right corner of chloride radical. Now after writing the valencies, they are always reduced to their lowest numbers if possible. Now here you can see the numbers 2 and 1, they are already in their lowest forms, they cannot be reduced further. So we will continue with the next step, that is interchanging of the valency numbers. Now here the valencies of both the radicals are interchanged with each other. That means the valency of calcium will go towards chlorine and the valency of chlorine will go towards calcium. After the interchanging of valency numbers, the valency numbers are written as a subscript. Subscript means at the base of the radical. And this subscript number indicates the number of atoms of that particular radical. Now here after interchanging the valencies of calcium and chlorine, we will get Ca1. 1 is the valency of chloride radical which is interchanged and has been written in front of calcium as a base number or as a subscript. And Cl2, where 2 is the valency of calcium which after interchanging has been written as a base number or as a subscript of chloride radical. Now, when we write down the final formula, we always ignore 1 as a base number because the symbol itself represents one atom. So, we do not need to write 1. Until and unless the number is greater than 1, we do not write it in the final formula. So, the final formula for calcium chloride will be CaCl2 and we will ignore the 1 which was written in front of calcium. Now let us have a look at the next example of magnesium oxide. Now magnesium oxide is made up of two radicals, that is magnesium radical Mg2 plus and oxide radical, that is O2 minus. Again we will follow the same steps as we have followed in the earlier example. In the first step we will write down the symbol of these radicals. The symbol of magnesium radical will be Mg and the symbol of oxide radical will be O. When we will be writing the symbol of these radicals, we will be ignoring their charges. After writing the symbols, we will write down their valencies. The valency of magnesium is 2, which is written at the top right corner of magnesium, and the valency of oxygen is also 2, which is written at the top right corner of oxygen. Then the next step is reducing the valency to the lowest ratio if possible. Now here if we see both the elements are having the valencies of 2 and 2 which can be reduced to their lowest forms. So here we are dividing them with a common factor 2 and then finally after reducing the valency to the lowest ratio we will get Mg1 and O1. Now once the valencies are reduced to their lowest ratio, the interchanging of the valencies is done. Now here you can see the interchanging of the valencies between the magnesium and the oxide radical is taking place. After interchanging the valencies, The valencies are written as a subscript or as a base number in front of the radical. So in front of magnesium 1 is written, which was the valency of oxygen and was written as a base number in front of magnesium. Then the valency of magnesium here was 1, which was written as a base number for oxygen. Now when we are writing the final formula, we have to ignore the base number if it is 1. Now here both the radicals are having base number 1. So we will ignore their valency base numbers and we will write down the formula as MgO.